So the next section we're going to cover is the second part of 4.4. The other day we talked about adding and subtracting expressions. Did have some unlike denominators in there, but we just worked with monomials. Today we're going to work with polynomials as well for adding and subtracting various expressions. One of the things I wanted to talk about first off when we're talking about adding and subtracting polynomials is kind of the term about the least common multiple of things. One of the things that we want to be able to do and we have to be able to do is we have to be able to identify the least common multiple of a polynomial. Of monomials, it's really not that bad. When you've got a 2 and you've got an 8, the least is 8. Can get a little bit more trickier when we're talking about polynomials. So we're going to start out here by finding what we call the LCM, as being able to identify the least common multiple of something. So let's say that of polynomials. So let's say that we have the two polynomials, x plus 2 squared, and then our second one is x squared plus 5x plus 6. And we want to be able to find the least common multiple of these. Now, keep in mind, when we're finding the least common multiple of things, what we're trying to do is we're trying to find the product of the factors where duplicate factors are raised to the greatest power that is represented. So you've got to factor things, or like in this case, x plus 2 is already factored. There's just two of them. So x plus 2 is actually raised to the second power in that example. So when we're trying to find the least common multiple, the first thing we want to do is we want to make sure they're in factored form. So the first one we've already got in factored form. The second one, we've got a trinomial. We're going to go ahead and factor it, and it factored is x plus 2, which we have in the first term, and then x plus 3. So when we're talking about common multiples, you're taking the product of these, and if they have anything that's repeated, then that goes to the greatest exponent. So I just usually start left to right, and I write it to the greatest exponent. So if I'm doing the LCM of this, I'm going to write that squared. Now I look at the second one, and I notice that I already have the x plus 2, so I don't have to add it in there. It's not risen to a higher power, so then I don't go any further with it. Then I just go to the next thing. Oops, I should probably use an actual color that actually works. And the next thing in there is x plus 3. So this then is the least common multiple of that piece of it. Okay, so you factor, you take it to the greatest power that it's represented for. Let's look at another example. Let's go ahead and find the least common multiple for x cubed minus 9x. That's our first one. And then we're going to go x squared minus 2x minus 15 for our second one. And this time we're going to have 3. That's x squared minus 5x. Okay. Now, again, probably technically speaking, I mean, you could just say all of these are the common, but then it doesn't become common and you become issues. So we're going to go ahead and factor these. And sometimes you simply can't eliminate things. So let's see. So if we take out an x, that leaves me with x squared minus 9. But I notice x squared minus 9 is a perfect square. That is a difference of squares. So I have to factor that. So that becomes x times x minus 3 times x plus 3. So there's the factor of the first one. Now I go ahead and I factor the second one. And again, you could use the x method if you needed to. I'm just going to go ahead and do it. It's x minus 5. It's not x minus 5. Yeah, it is x minus 5 times x plus 3. There's the second one. And the last one, take out a common factor, it's x, and that leaves me with x minus 5. So now when I'm finding the least common multiple, I just start with the first one and I write all the terms down. So I've got an x, I've got an x minus 3, I've got an x plus 3. And I take it to its highest exponent, so those are all at the highest exponent. Now I look at the second one and I say, okay, is anything repeated from the second one to what I already have written down? The x plus 3 is repeated. So I don't need to write the x plus 3 down. I just need to write the x minus 5 down. The x plus 3 was repeated. I already have it. I don't need to add it in there again because I'm on a different term. Then I go to the last term. And I look at the last term and I compare it to what I already have. And if anything is repeated, I don't have to write it down. If it's not there, I have to write it down. Nothing else is repeated in this one. So everything is already there. So my least common multiple for this one is that right there. And that's the least common multiple. And we really, when we're talking about adding and subtracting these, we have to be able to find that least common multiple because essentially that's going to become our new denominator when we do these. Right? So then that leads us into adding and subtracting rational expressions with unlike denominators. Okay, so let's just look at an example. Let's go with x plus 3 over x squared minus 1 plus 2 over x squared minus 3x plus 2. Okay, so we got to find that common denominator, which is the least common multiple. So that's the first thing I'm going to do. I'm going to say, okay, we've got to find that LCM. And that LCM is going to be my new denominator. So let's find the LCM. In order to find the LCM, the only ones I really care about are the denominators. I don't care about the numerators, unless we can cancel something out. But so we're going to factor, and I'm just going to write it underneath there. This is a difference of squares. So that's factored. Next one, x, it's plus, so x minus 2, x minus 1. Does that work? Yep, that works. So our least common multiple then, when we're talking about our least common multiple, I just start out, I go from left to right. So I've got x minus 1, x plus 1. Now I look at the second one and I see if anything's repeated. I notice that I've got an x minus 1 in both of them, so I don't need to write the x minus 1. It's already written down. So the only additional thing that I have to put in here now is x minus 2. So that's my least common multiple. So now that's going to become my common denominator. It's going to become my least common, or my denominator. X minus 1, x plus 1, x minus 2. So I've got x plus 3 over my original, and I'm going to put it in factored form, which is x minus 1, x plus 1. Now, I want this to be x minus 1, x plus 1, and x minus 2, so I have to add an x minus 2 into the denominator. If I add an x minus 2 in the denominator, I have to add an x minus 2 into the numerator as well. Plus, I've got 2 over x minus 2, x minus 1. If I look at them and I say, okay, what have I added in there that's different? I have x minus 2 and x minus 1. I don't have an x plus 1, so I have to add an x plus 1 in there because these two things have to be the same, in different order, but that's okay. So since I've multiplied x plus 1 to this one, I got to multiply x plus that 1 to that one as well. Okay. So now we're at the point where, we take care of the top. We got to do the distributive property on the top and go ahead and solve from there. As you can see, I'm going to run completely out of room here. So I got to move some things up here a little bit. I got overzealous a little bit and ran out of room. So move them up, cause some headaches for myself. That's okay. So I'm going to distribute. So x times x is x squared minus 2x plus 3x minus 6. And then I've got a plus sign, so I can just go plus 2x plus 2. Combine like terms. If I combine like terms, that leaves me with x squared. I've got minus 2x plus 2x plus 3x. So plus 3x, got minus 6, so minus 4. All of that over x minus 1, x plus 1, and x minus 2. So again, we're going to have to keep going here. This one's not done. I'm going to have to go to another page because of what can be done with this one. So just a continuation. So we had x squared plus 3x minus 4 all over x plus 1, x minus 1, x minus 2. I think that's what we had. Okay. Now we have to look at that top part and say, okay, now we've really done the adding now. Now we need to see if we can simplify this a little bit more. So we look at that top part and say, okay, can we factor that? I think that factors into x plus 4 and x minus 1. Yep. So then that's x plus 1, x minus 1, x minus 2. Now we've got this x minus 1 and x minus 1. So our final solution to this is x plus 4 over x plus 1 times x minus 2. That is our solution. Okay. And are there what we call excluded values in there that couldn't work? Yep. Okay. And we're talking about excluded values. We really need to talk about way back to probably the original question. Or we can even look in here to figure out, okay, what are our excluded values? So for what values doesn't x work? If we look right here, x cannot be -1, 1, or 2. Those are my excluded values from that. And you need to go way back to there to figure out what your excluded values are going to be, because that's your common, that's your least common multiple. Right? So there's one example of adding. Okay. Let's look at another one. Let's go with x plus 6 over x squared minus 4 plus 2 over x squared minus 5x plus 6. It's a nice plus sign in between them. All right, so we're going to factor. So change colors here. Let's go ahead and factor x minus 2, difference of squares, x plus 2. Factor this one, x minus 2 and x minus 3, a minus and a minus. Make sure you double check these when you do them. That looks good. Okay, so I'm not going to list the least common multiple this time. I'm going to go ahead and just write out what we have. So our new denominator, start at the left, x minus 2, x plus 2. Go to the second one, x minus 2 is already covered. I don't have an x minus 3, so I have to add in that x minus 3. So that means on the top, because I added in that x minus 3, I have to add it in there. Those would cancel and we'd be good to go. Back to the same. Second denominator has to be the same, so we can't change the denominator. So it's going to be, now our denominator is x minus 2, x plus 2, x minus 3, and I've got a 2 on the top. But now I compare these two and say, what's been added? Well, the x plus 2 has been added, so that means I need to go x plus 2 right there. Now distribute, and to kind of quicken it up a little bit, that's x squared minus 3x plus 6x. So minus 3x plus 6x is plus 3x, minus 18, and I'm just going to worry about the numerator, plus 2x plus 4. Again, I'm just going to worry about the numerator. I'm not just going to, because I'd just be rewriting the denominator anyway. So that's x squared plus 5x minus 14. Now all of that is over x minus 2, x plus 2, x minus 3. So is that technically, I was lazy. And now I have to look to see if it can be reduced anymore, so I check it. Looks like this can be factored to x plus 7, x minus 2. And you always have to check. It's not always going to happen, but it does happen. So now I've got an x minus 2 in both the numerator and denominator. So we get a final answer of x plus 7 over x plus 2, x minus 3. Our excluded values. We go with their excluded values from what our least common multiple was. So x can't be 2, negative 2, or 3. So there's your solution for that one. Okay. So that's finding the sum and finding that least common multiple. So now let's look at talking about finding the difference between two of them. Really, the process, you're still going to find the least common multiple or least common denominator. It's the same thing. It means the same thing. Least common multiple, least common denominator. It's the same thing. You're still going to do that. Now you just have to be a little bit careful with some things. So let's go with x plus 1 over x squared minus 6x minus 16 minus x plus 1 over x squared plus 6x plus 8. All right, so find the least common multiple. So it's got to be step 1. So we're going to factor. And again, I'm just going to kind of do it quicker. So x minus 2, x plus 8. Look right? Yep. And then this is going to be x plus 2 and x plus 4. Ooh, I messed that first one up, didn't I? That doesn't look right. So erase that. It is not right. I think it's x minus 8, x plus 2. Let's try that instead. Yep, there we go. Sorry about that. How did I know I was wrong? There weren't any that were common, so I thought, oh shoot, something must be wrong. So fixed it. All right, so now I'm going to do this a little bit different. I'm just going to make one huge line now. And I'm going to put my least common denominator on the bottom. So I start at the left. So x minus 8, x plus 2. I've got the x plus 2 already, so I got to go with x plus 4. So I'm going to start out now by writing this x plus 1. And I'm going to put it inside parentheses. Now I'm going to compare this to this and say, okay, what have I added in there? I've added in the x plus 4. So that means that I need to multiply this by x plus 4. Minus, now I'm going to put a huge parenthesis around this. And as you can see, I probably made it too big because I'm going to run out of room. I've got that x plus 1, but now I compare these two and say, okay, what has been added in there? And what has been added in there is the x minus 8. So since the x minus 8 has been added in there, I'm going to put an x minus 8 in there. Again, notice I got all these parentheses because it's that key is we're subtracting this. So since we're subtracting this, we've got to use, we got to use that minus in there because that minus is going to have to distribute. Now, I know I did it a little bit different this time. It's the same thing. I just put them all in one thing instead of rewriting it again. A little bit of laziness, but make sure you compare. Okay, so we take care of the top now. Oops, so we've got x times x is x squared. We've got plus 4x, so we've got plus 5x plus 4 minus, and now I'm going to put a parentheses, x squared minus 8x, so plus 1x, so minus 7x minus 8. Okay, and all I've done was dealt with this part right here. Now I've got that negative outside, so I've got x squared combined like terms. X squared minus x squared is nothing. 5x minus negative 7x. 5x minus negative 7x is 12x. 4 minus negative is 12, so plus 12. And I can see I can factor that to 12 times x plus 1. I don't know if it's going to do any good, but I could certainly do that. Okay, so now I've got 12 over x plus 1. That's my numerator. Now I've got to put my denominator back. X minus 8, x plus 2, x plus 4. This is your solution. Now, again, I'm saving myself some writing. Okay, remember this denominator, this least common denominator, least common multiple, that's underneath this. Okay, I just got lazy and just figured out what the numerator was. Because the denominator we know is going to stay the same throughout the thing. You just make sure you put it all in at the end. Figure out our x values. That x can't be 8, negative 2, or negative 4. And there's your solution. Okay. Let's look at one more of those. Let's go 3x minus 5 over x squared minus 25 minus 2 over x plus 5. Okay, so I'm going to factor first. That's x minus 5, x plus 5. It's already factored, so I don't need to do anything with it. So write out my least common denominator, and again, I'm just going to write it once. X minus 5, x plus 5. And another way that, just to kind of show you a different way to do it, what some people do when they do these, and it's a good way to do it, and there's nothing wrong with it. It's just another way, so I'll show you a different way maybe to do this instead of how I just did it. If I compare x minus 5, x plus 5, again, that's my least common denominator. If I compare the first one, I haven't done anything with it. Minus, now I got to put a huge parenthesis. Now I compare these two, and this can save some writing, so I don't know why I don't always do it, but whatever. If I compare, I don't like that color. If I compare these two, what's not on the top one that's on the bottom one? Well, x minus 5. So that means I need to take that times x minus 5, and I need to take that times x minus 5. And now I can just do this distributing right here. So that's 2x minus 10. Don't worry about the plus minus sign. Don't worry about that up here. We worried about it down here. We've got it down there, so we're okay. So now we can combine like terms. So we've got 3x minus 2x, which is just x. Negative 5 minus negative 10, which is just 5. All over x minus 5. X plus 5. The x plus 5s divide out, so we're just left with x over x minus 5. Again, our excluded values, x can't be 5 or negative 5. So there's your solution. So there's adding and subtracting polynomials. We're still not quite done with this section. We still got one thing left to talk about. We've got to talk about what we call compound fractions and how we go about working with compound fractions or simplifying compound fractions. So we'll talk about that during the next lesson. But for today, you're going to concentrate on working on adding and subtracting polynomials. With unlike denominators, you're also going to be asked to find the least common multiple as well. So yeah, be a worksheet that you need to get taken care of. So you get that worksheet taken care of. And then and go on to the next lesson, which is about compound fractions, I believe. Yep, compound fractions. See you in the next lesson.